the fact that I jumped into 2 dimensions and you guys were picking up. Okay.
Speak person.
Darkness. Wait, the one we turned the light off.
On the video. And, well, you, Taylor, asked me if I would record this.
Oh.
Go ahead, Taylor, say some more funny things.
No. Oh,
Talk to us about Dylan. What do you think about Dylan?
He smells bad.
He's what?
Okay.
Well, it's one.
So, in this, we left off on this yesterday, talking about the 2 dimensions. And I did this for a purpose. I wanted to show you just how complex this stuff can get. Okay? You have to be able to think mentally of breaking things down within terms of this. And things have changed. The normal force is no longer equal to the force of gravity. The force of gravity and the y component. Things have changed. Alright?
Do they really?
So, you have all sorts of different little situations.
It's just such a number.
Friction's the one that we left off with, and I was talking about how it can really mess you up if you're not thinking hardcore about it. So in this case, make sure that you're thinking, what's the key with friction?
Moving and not
something
moving.
Moving and not moving. Okay?
Static.
What type of friction is it if it is not moving?
Static.
Static friction is it's not moving. What type of friction am I looking at if I'm trying to figure out if an object is moving?
Kinetic.
No, static. I'm seeing if it is moving because remember, static friction will always be greater than kinetic friction.
You pulled a trickery on me, Mr. Hall. I thought you were asking for something if it was moving.
Rough on maybe.
Alright? What type of friction is it if it's in motion?
That's kinetic. Once it moves, it breaks static and goes into kinetic.
What is the key with the normal force?
It's perpendicular to. Okay, you're so smart.
Perpendicular to the surface. Awesome job.
You looked at me and I was like, oh no, I said it wrong.
No, you were hesitating. You started backing up and I was like, oh, she's going to be wrong. And then I was like, no, she's right.
Yes, sir.
Alright, so then within this,
He doubts us.
a little bit.
It's okay, I doubt myself too.
So within this, you can have different little certain circumstances, cases that can take place. So let's say, for example, Mr. Hall has a cannon.
Wait, do we ever finish the top problem?
Yeah, I'm just breaking it down.
Well, that was static, right? That was a static problem.
Yeah, it's fine. Because I told you to look with me.
Alright.
Alright, so in this, let's say for some reason Mr. Hall has a cannon. Yep, I
A
did.
physics cannon
Yeah.
that shoots physics problems at our tearful faces.
So in this,
Where's Clay?
here's this cannon. Now let's say this cannon, in terms of relation with ground, which there's ground, is at a 22-degree angle. Now let's say for some reason, just randomly, Mr. Hall decided to shoot a pumpkin out of it.
Alright, reflex.
Happy fall.
And out of that pumpkin, out of that cannon shot this pumpkin, and let's say that it shot out with a velocity of
4.32
4.32 what?
meters per second.
Meters per second.
Square. No, would it be square? No.
No.
That's
All right, so
gravity.
in this case-
I was thinking of gravity. I was thinking of gravity. Nobody think I'm stupid.
Too late.
Were you really thinking?
Yes, I was. At least I had a thought. I never had.
Well, your initial position would be that. I meant your initial velocity.
The initial velocity is that, but here's the key. That initial velocity is this right here.
It's what?
This, ladies and gentlemen, is a vector. And within this vector, there's a problem. You will not be able to solve problems like this in keeping these things together. So you need help.
From X and Y.
Those are good things.
From trigonometry.
Trigonometry, yeah. So in this,
Let's get trigged up.
I'm gonna throw up.
let's say you have this right here is
Hold that trigger.
the 4.32 meters per second.
Do you have a letter opener?
No.
Okay.
22-degree angle. And here's where things get fun. What can we do?
Well, you have a side and an angle. But I don't know the formula for that.
No, that's fine, because think about this. What did I tell you could do with resultant vectors? They break into what?
X and Y.
X and Y vectors, the component vectors. So in this case, if I break this down, this right here, is it vertical or horizontal?
What's your Y?
Vertical, so that's the velocity in the Y direction. And this here,
Your velocity and X.
is our velocity in the X direction. Just before anybody says, that's not a right triangle.
Oh,
There's my box, tell me it's a right triangle, so
I
you
said
can't
it.
argue. So in this,
You need to put not drawn the scale whenever so nobody can say that.
Is it possible for us to use the trigonometry formula to figure that out?
yes. Well, yes, it
Because I
is.
still have my trig notes.
Yeah.
That's very good. Hopefully you have some trig knowledge though. Because in this,
Just for you, organizing.
think very simplistic.
Yay.
A squared plus B squared.
Pythagorean. Is that what we're using? Are we using a squared plus b squared?
SOHCAHTOA.
I thought you said we didn't need to know all that SOHCAHTOA stuff.
Oh yeah.
Why don't you just follow me?
Sine over.
You know what he says to that? Something.
Sine is opposite over
Hey,
hypotenuse.
hey Dylan, what trig class did you take that wasn't based off SOHCAHTOA?
Well, yeah, I know, but we said we didn't have to worry about that. I mean, I know.
I said you didn't know like all the like identities, like sine squared, theta plus cosine squared, theta. All that.
Still, I don't even want to look at that. I know it, but it makes me cute every time I look at it. Sine equals opposite over hypotenuse. Cosine is opposite over adjacent, and then tangent is opposite over.
You wrote that down.
Isn't it C-O?
What's it called?
I like to make
Our
sure.
person
Yeah, your TOA is
Ah.
H. Yeah.
I was so confused.
Oh, H.
That's
That's
not
Dylan said that.
Ain't that like a
That's wrong.
I messed up right there.
Yes.
ain't that AH?
Yeah.
SOHCAHTOA. And all
So
all
color
students take calculus.
Yeah.
That was wrong.
Yeah, all students take calculus. I hated that one too.
Yeah, all students who take
Oh, I'm
calculus
gonna puke,
are
Mr. Hall.
mentally dying right now. I'll tell you that.
Why?
We're tired.
Listen, I've helped y'all out. Y'all do a lesson in there that y'all should have no problem just sorting
Yeah,
out.
she said physics.
I never thought I'd hate better math class worth the trade, but I hate that.
God, I hate it.
All right, so in this case, we need to find these. So in this case, we're going to start with initial velocity in the x direction. So in this, in terms of trying to find that, you have this angle in everything that we're looking in reference from. So pretty much, hopefully you can see which one of these it'll be, sine, cosine, or tangent. I'm at this angle, and I'm trying to find this side. And I know my hypotenuse. What am I going to use?
Cosine.
Cosine! Thank you. So I'm going to write it in cursive just because it helps me out with things. So cosine of 22 degrees is equal to adjacent.
Can't you just put that in the calculator?
Yeah.
Yeah, but we got to move some things around. 4.32 meters per second. So in this, we will find that the initial velocity in the x direction is equal to cosine 22 degrees times 4.32 meters per second. Any issues there?
Oh.
Let me make sure I'm in degrees. I'm in radians.
How much harder is this going to get you? This is going to be like the worst one yet. This seems better than anything.
This is better than the last lesson.
This one just more math or what?
Alright, so I get cosine of 22 equals that decimal there. And then I just took that decimal times 4.32 to give me an answer of 4.0054 meters per second.
So do you have to go back and do the velocity for
Sorry?
the initial velocity for one now?
Now we're going to do the initial velocity for the y. I told you, this is not this bad. Like, you have trig as a prerequisite, but this is not the hard, like, the hard stuff in trig.
Could
You're
you
just
do-
applying it.
You could do
Could
sine
you
over
do Pythagorean theorem to get your other side?
You can. Now. But I don't want to do it.
Yeah, now.
But you absolutely can. That's totally fine.
Okay.
Me, I'm going to do the sine because it's the opposite side. So sine of 22 degrees is equal to the initial velocity in the y direction divided by 4.32 meters per second to get me to where my initial velocity in the y direction is equal to, I'm going to do 4.32 meters per second times the sine of 22 degrees. And we will find that to be, hand it in calculator, and that's what I get right there. I get 1.6183 meters per second. Hey. Now here's the key and stuff. This is the initial velocity in the y direction. This is the initial velocity in the x direction. Okay? All that's important. I'm going to save that information on the screen so I can copy it over to my new next sheet. So I found. Give me a second, I'll have some time.
No, it's probably going to be harder. He's going to be like, ha 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 ha.
Yeah, is this as hard as it gets?
He's like, okay, I gave you those. Now find the.
Find me the gravitational force of Mars.
Yeah, exactly.
Like, honestly, these quizzes are like in here it's like, okay, what's 2 times 2? And then you get on the test and it's like, what are we having for lunch tomorrow? And I'm like, what? That's every class.
Homework. 2 + 2 = 4.
It's like
Test.
3 times 400,000, blah, 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 blah.
Alright, so
Also,
going
what's
from
the color?
what we had.
Of
All I
my
did is I
socks.
copied down the information from there which we solved for. And I want to use this as a thought sample for you, okay? This is the key in this. If you're going to solve something in those dimensions, you can only use what you have in the x direction for x direction calculations and what you have in the y direction for y direction calculations. Staying in terms of just this little thought example here, staying in terms of me firing a pumpkin out of a cannon.
So do you have to like solve for everything in those specific directions?
Yes and no. Okay, because like in this case, just sticking with it. Let's change my colors. Green and purple. Alright, so we have the initial velocity in the x direction. So final velocity in the x direction. We would have an initial position in the x direction, a final position in the x direction. We'd have acceleration in the x direction and time.
Oh, is time just the same for each direction it is?
Look at you. It absolutely is the same, which I was going to use as an example for something. So then I have the final velocity in the y direction. I have the initial position in the y direction. Hey, does that look familiar to y'all now? Now you understand why I used y?
Oh, I'll put X.
That's fine. Then I have final position in the y direction. Then I have the acceleration in the y direction. And then I have time. Why is it that time is not getting labeled x direction or y direction?
Because it's the same.
It's the same in both cases. It doesn't matter what you're looking at. Time is what will link the two together. So time links together.
Allie Morgan, Brittany Cunningham to the office.
Now think with me for a minute here. Let's go to the y direction because I feel like the y direction is the one that you guys will grasp really, really quick. Let's talk. Let's start with acceleration.
Well, it's going up. Wait. Yes.
Okay.
Okay.
Is there an acceleration going on? Now I'm talking in terms of after it leaves the cannon.
Oh. Well, yes. Because it's going to go, and then eventually it's just going to go to the ground.
Gravity is pulling it down.
Gravity's negative.
So acceleration and gravity.
So acceleration is gravity. Why? Because it's gravity's still in effect at all times. Okay? It's the same thing as a football player. When the quarterback throws the football, what brings the ball back down?
Gravity.
Gravity. So in this case, 9.81 meters per second.
Square.
Nah,
See, that's
square.
Yeah.
Okay? And then you got different circumstances that can be talked about. Let's go over here to the x direction though. Let's talk about the acceleration in the x direction. What's acceleration in the x direction?
It's going side to side.
It's going side to side, so the gravity.
So gravity's
zero.
not playing point, so you have to solve for your acceleration, maybe.
Is it zero because there's 6 already? You have 4 around?
What pushed the pumpkin out of the cannon?
The force of
Of
the...
the cannon. Well, once it left the cannon, what's happening?
It's just flying. What about like air resistance? Is that a thing?
Gravity is not.
We ignore air resistance in this class because it's complex and things a lot more difficult.
But it is a thing though. Like,
Yeah, it does exist.
so you just thought of it yourself.
Don't tell me it's gravity.
Don't tell me gravity plays a part, 'cause it's going side to side, gravity not playing a part. Okay.
That's what
I was
Now,
about
why
to
would
say.
it be 0 meters per second?
Think about what made it accelerate in the x direction.
The cannon.
The cannon.
That's cannon, yeah.
Is the cannon acting on it anymore?
No.
No.
So it's 0 meters per second.
I said it was.
Yes,
There, just
okay, but I didn't yell it out and say, yes, Riley, you're correct. Julie
You
also
just
said
looked at me
gravity, but then I
funny.
didn't look and say, yes, Julie, you're correct.
You looked at me funny though, like I was wrong.
I looked at Julie too. Y'all just think I have a mean, like, hey, you're
No,
wrong
you're just like-
stare.
You really do.
You like that?
That's the problem. You definitely do.
It's all about how you take it.
So this is the thing I wanted to focus on here. Time is the same in both. Acceleration from within the X directions, there's none. Within the Y directions, you still got gravity to take into account. Now, situations can change. If I change and I take you off the surface of Earth and I put you on the surface of the Moon, is that gravity? No, gravity is then changed. Okay? So in this case, whenever you're looking at it, what would the flight path of the pumpkin look like?
Like this.
Wait,
What angle is the cannon at?
22 degrees.
Okay, so
Just go, yeah.
it goes up and then down.
So it looks something like that. Right? So let's say
Bro, she really drew a cannon. That's commitment.
There's a slight curvature. Or is that the heel of the cannonball?
That's not really slight. Okay.
Is it a rainbow?
Huh?
It's not slight.
That's a slight curvature.
I can't help it. I'm dealing with myself today, evidently.
Alright, so at these points, you're going to find certain things going on. So this would be like time 1. Here at time 1, special things taking place. This is whenever this is whenever the pumpkin is fired from the cannon. So at T1, this is when you have what we calculated as these initial velocities coming in at. Now in this case, whenever you look at it, the acceleration of gravity, so let's do this. We'll do T1, here at the highest point we'll make T2, and here at this third point we'll make T3. Alright, so in terms of T1, let's talk about what's going on.
It's being shot out.
It's been shot out, so we have our initial velocities of which we've solved for. So the initial velocity in the Y direction is 1.6183 meters per second. We also have
And then T2 would be the X, wouldn't it? No?
No.
T3 would be the X.
we also have the initial velocity of the X direction here being 4.0054 meters per second.
Oops. So the
At this time, what would we have time equal to? Zero seconds, because we're just now starting the problem. We're starting to look at the situation that we're facing. Moving a little more from here. What could we look and say that the position in the X direction was?
Zero.
0 meters. And then comes an interesting thing, and I'm going to let you all make the determination of it. What could we say the initial position of that Y is? Which really, these are not initials, they're just the positions and values and stuff. But
1.
0.
I don't know.
here
Just
in 1,
say
here in 0, what y'all want to make it?
I don't know.
I think it's because of 0.
Okay, 0.
0. I just thought it was gonna be some voodoo stuff. He'd be like, "Oh, but it's not 0."
Was that a bad thing to do?
No, it's totally fine. Okay, so in this case, let's talk acceleration. In the X direction, we've said is 0. Should that in green. Acceleration in the Y direction, we've said is gravity, which is 9.81 meters per second squared. So now we got to start making some decisions here.
Is up or down going to be negative or positive?
That's what I was going to ask.
Well,
4K.
What do y'all think?
I say just keep positive.
Up, positive, down, negative.
Okay, so down is negative, and up is positive. Everybody good?
Yeah, sure.
Yeah.
I missed orbital rotation.
Bro, me too.
Yeah, that's a move.
All right, so this is at T1. This is when the problem first takes place. Now you're going to find yourself, and all I'm doing this for is thought process. I want you to be able to think through some things. Okay, so let's look right here. Let's move from T1 and let's go to T2. Look at the curvature that you got. This is the highest point. At this point, does the pumpkin go any higher?
No.
No.
So you could say here is my highest point. So talk with me about this point. What do you think is going on with velocity in terms of y?
Why? Isn't it like slowing down or something?
Oh, you guys made a determination here. That's got to be negative.
Oh.
So talk with me.
And I'm gonna go like slowing down or something.
It's like less than, or they like less than or equal to? Because like that's
Friction.
It's equal to something.
0.
Why do you say 0?
Because it's like slowing down, so it's highest point, so it ain't gonna go any further. It's just gonna drop.
Alright, so you're saying that's where it
It's like
stops
when
and
you're
now it's
talking,
on
it's
its
like
going
when you're
back on
talking
its
about
way
the
down.
meeting, when you said you were like, when you would like throw the tennis ball or whatever, there's a part where
There's
you
that part
stop.
where it hits that 1 second where it stops
Right.
and then it comes back down.
Yeah.
Okay.
That's exactly why. It reaches a point to where the velocity in the y direction becomes 0. That is your highest point, because then what happens then? It doesn't increase in height, but it starts going down
Gravity.
back to where it had came from.
She told me to make it to the snow.
Okay? So talk with me here again. Let's look. See what y'all are thinking about the velocity in terms of x.
Well, I think it's the same maybe because you're continuing.
Savannah Atkins, Haley Morgan to the office. Want to remind faculty that there is a PLC tomorrow after school from 3 to 5. Also a reminder to girls that are wanting to try out for basketball, you have to have a physical before you can try out tomorrow. There will be no exceptions. Tryouts will be 3:15 to 5 o'clock. Also a reminder to seniors that Thursday is a FAFSA day. It's very important, if you have not already completed your FAFSA, that you get it done on Thursday. If you have any questions, go see one of the counselors in the counseling office.
Alright, why
Thank
is
you.
this the same as it is up here? The acceleration in the x direction is 0. It's not slowing down, it's not speeding up. It will maintain the same velocity. So then,
Wait, why do you have an arrow pointed up?
I'm letting you know this is why.
Oh.
Because acceleration in the x direction is 0. Alright, so in this, time is equal to what?
Well,
Would be 0, right?
something. Like,
Something? Okay.
What?
because we don't know it yet.
For some reason, I thought that was 50 me instead of some. I don't know why.
So it's equal to something, but what would you have to do to find something you have to calculate
Your
for?
formula.
Yep, you're going to use formulas, you're going to calculate for it. So then talk with me here. Let's do x position equals what?
Well, we don't know.
So,
So I put something.
something. We can solve for it. about the Y position.
Something.
It's absolutely something. But the key with it here is that something is highest point. Is there acceleration in the X direction? No, it doesn't change anything. Is there acceleration in the Y direction?
Yes.
What is it?
Gravity.
Still gravity. Just because gravity slowed it down doesn't mean it stopped. It's going to then take the pumpkin from here and make it come back down. Because what goes up must come down, right?
Yep.
Yep.
So then, look at T3. T3, what can we say for it in terms of velocity in the Y direction?
Should be 0.
Well, it's already hit the ground.
Oh, okay.
I know what you're thinking. You're thinking in terms it should be 0 if it hit the ground. But in this case, I'm not giving you enough information to determine whether it's hit the ground or not.
Okay.
So in that case, we're looking at having to say it's at the same point. What knowledge can we know about the same point? Now, if that's the ground, it hits the ground, it's 0. But right here, it's the same velocity but opposite sign because it's traveling in the opposite direction now.
Okay.
Yeah, it's like
So what can you say about the velocity in the X direction?
it is positive, but
It's the same thing you solved for. Nothing's changed there. It's staying the same until it hits the ground. Once it hits the ground, then yeah, it's going to be 0. It's going to stop. Time?
If someone borrowed my keys yesterday afternoon, could you please return them to the office, please?
Is something.
This is Melanie.
She's like going on her voice.
What is the X position? The X position is also something you can solve for.
Why wouldn't T1 and T3 just be the same if they're at the same level on the same level? Wouldn't they be almost the same?
Time? It took me time to get from here to there. Y is equal to what?
something.
Nope. 0 meters.
Okay,
It's the
cool.
same position in the Y direction. It's different in X because you've traveled over. But it's the same in the Y because you've went from here up, back down. Okay.
Okay.
Any questions?
Not at the moment.
Tomorrow we'll break out. We'll break these whole thought process down. We'll give you some formulas that won't be too confusing for you, and we will break it into solving problems.